Many of his closest colleagues genuinely suspected that they were interacting with a superior intelligence, perfectly simulating humanity. His mental processing speed actively humiliated the very electronic computers he would eventually help design. This was John von Neumann. He was the mind behind the architecture of modern computing and the architect behind humanity's most devastating weapons. Born into an affluent family in Budapest in 1903, he developed an eidetic, or photographic, memory almost immediately. By age 6, his family used him as a parlor trick. A guest would randomly select a page and column from a local phone book. The young boy would read it once, hand it back, and flawlessly recite every name, address, and phone number in perfect sequence. Decades before engineers could etch logic onto silicon microchips, humanity's most efficient processing unit was the biological hardware sitting inside John von Neumann's skull. In the early 1920s, the scientific community hit a massive bottleneck. The mathematics required to understand quantum mechanics were becoming entirely too dense for traditional human cognition to resolve. Von Neumann stepped into this mathematical chaos. In just 24 months, he systematically built a rigorous, solid mathematical framework that allowed physicists to actually calculate quantum behavior. While he was actively solving the foundational equations of the physical world, he maintained an incredibly chaotic social calendar. He spent his evenings throwing loud parties and navigating the bustling cabaret circuits of Berlin. He possessed a rare capacity to take impossibly dense physics and translate the concepts with lucid clarity for laypeople. After a conversation with him, people often walked away feeling that quantum math was actually simple. His lifestyle was loud, messy, and deeply human. But his mathematical output was mechanical, flawlessly compiling and decoding the source code of the physical universe. Fleeing a destabilizing Europe in the 1930s, he took a post at the newly founded Institute for Advanced Study in Princeton. Here, he worked alongside legendary peers like Einstein, completely outcalculating most of them. During World War II, the military recruited him for the Manhattan Project. He was tasked with calculating the incredibly complex, nonlinear hydrodynamics required to trigger a nuclear implosion. This animation illustrates game theory's minimax theorem. It mathematically models human conflict, showing how opposing forces constantly recalculate optimal moves to find equilibrium. But modeling global economics while calculating nuclear explosions created a computational bottleneck, too large for one biological brain to hold. Confronting the absolute limits of human cognition forced him to pivot. If he could no longer process the equations internally, he had to build an external machine that could. He turned his attention to automata, the logical architecture required to make massive electronic calculating machines work. As this diagram shows, he realized complex data could be stripped down to simple binary states. He championed the bit, a single 0 or 1, as machine memory's foundation. This efficient architecture allowed memory to scale exponentially, entirely solving the processing bottleneck. By the 1950s, he sat in rooms exactly like this one, advising the military and the Atomic Energy Commission. He was effectively operating as the central processor for the United States government. He successfully finalized the blueprints for an immortal digital mind. But at the exact moment his new hardware upgrades went online, his biological body initiated a fatal collapse. At the absolute peak of his global influence, doctors discovered a terminal, incurable bone cancer growing inside him. For a man whose entire identity relied on pure, predictable mathematics, this caused immense psychological terror. He was trapped in an illogical biological failure that he could not calculate his way out of. Peers like the physicist Eugene Wigner watched helplessly. They saw the greatest intellect of a generation break down into sheer panic as his cognitive functions slowly failed. He received the highest civilian honors directly from President Eisenhower, but no amount of military influence or presidential awards could halt the physical decay. In February 1957, the most powerful biological processor in human history permanently shut down. But look at the architecture of our modern world. As this diagram shows, every smartphone, laptop, and global network we rely on today is still running entirely on the computational framework he designed. His mind didn't disappear. He systematically downloaded his logic into the machines that outlift him. John von Neumann mathematically calculated the modern digital era, and in doing so, he became its eternal operating system.